So they definitely want the temperature. They start getting concerned at about 103, 104, and they want to begin to take measures if other methods haven't worked. Under normal conditions, if your temperature goes up to like 100, you might be feeling bad. But if it doesn't really go much over that, leave it alone. Let it fight whatever is trying to invade. Don't take the Tylenol, don't take the Advil. Give it a day or two, please, because it's the body's natural activities trying to take care of the pathogen. And as long as it doesn't go over that, just rest, drink plenty of fluids, and hopefully it will cure whatever has invaded. So you need to start getting concerned when it reaches that 102 and won't go back down. Inflammation will occur because we want to limit the spread. Cells have come in. They are beginning to create the kill zone, that sort of thing. The cells that have made their way want to get rid of the debris or the damaged tissue. They want to initiate tissue repair for both the breach as well as the blood vessels. Usually the cardinal signs of inflammation: redness, swelling, heat, pain, whether we actually notice it or not. The processes that it's trying to do in the body: mobilize the defenses, get those cells in, get them ready for work, contain and destroy any pathogens that try to enter, help with, oh, I forgot a typo, I got a typo. Help with any tissue cleanup and repair at the site. Under normal conditions, this works. If they can mobilize, get materials to the site of the injury, use hyperemia, increasing fluid, okay, meaning blood vessels have dilated, we are getting the white cells to the area. We can, as they get to the area, they're actually sending out chemicals to bring in more. So that's what they're doing. They're mobilizing for the attack. Like I said, dilate the capillaries so that we can get more materials to the area. Do you guys remember this right here? When we talked about blood and how the blood has materials to start working to form a clot and so forth, this is part of it here. We need the blood cells to begin to form a clot. We need the we need the cells to come in and eat the stuff. Okay, phagocytize. Okay, there we go. I got it. All right. And if something makes it past this point, we're going to need our antigen-presenting cells. But everything up to this point has been nonspecific. It's going against any pathogen. If things are going normally, tissue cleanup and repair can occur. Usually, like for example, a paper cut, a splinter. If it happened this morning, do you even notice it that evening? Chances are it's done. Okay? It's on its way to healing and everything is good. It's when something gets bad and makes it past all these other defenses that we have to get specific. That is our third line of defense. Immunity. The third line means whatever the pathogen was, it has made it past everything that the body has put in its pathway. It's made it past the kill zone. It's made it past any type of chemicals that could be released to kill something. That cell is now inside the body and attacking cells, attacking the actual cells of the body. This is now my immune system that's needed. The immune system of our body, the goal, okay, I have a pathogen that has now made it past all these other defenses. We need to mobilize, attack, contain, and kill it. Now, we know things can go wrong. It's the reason we have autoimmune diseases, because this immune system that should be attacking something foreign is now attacking our own cells, which is the autoimmune. With this system, it's now going to be specific. Before, I kept saying, it's attacking anything, okay? This one now needs to get specific. Maybe it needs to go after the flu virus that has invaded you, okay? It's going to create memory. Basically, the first time you get exposed and the cells have to get put into action, when the attack is over and the body has healed. Now the first time you're exposed to this pathogen, the response is bad. You know, think about it. Okay, you get the flu. Anybody in here ever had the flu? It was awful. Okay? I mean, and the fever and the chills and the sick and the bleh, okay? But then you eventually begin to feel better.
But like when people get like one strand and then they get another strand, would the body not be able to build some kind of memory off of that? Is that why?
No. So in other words, like with the flu viruses, I don't know how many of you get the flu shot, okay? But the flu shot is simply made up of 3 strains. There's always an A, a B, and the one that they think is going to be the most prominent for the current flu season. So if they think that it's going to be a particular type of the B flu virus, that's what the 3rd portion of that shot will be. The goal, stimulate enough of your immune system so that the T cells come in, fight it, and build immunity to those 3. Okay? So if you're exposed to the 4th, oh, no, it's all new again. And you got to go through all the symptoms. You got to go through the fever. You got to go through the sickness and all that sort of stuff. But now you've got that immunity against it. But let's say 5 comes along. And like I said, you're touching stuff all day long. You're rubbing your eyes, you're eating, you're touching your nose, blah, 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 blah. And then all of a sudden you're sick with the flu again. And you're like, wait a minute, I got the flu shot. I've been sick. What the hummy's going on here? Well, it's because the body don't have the immunity for it yet.
But it, like getting the flu, that's like a generic term because it kind of mutates, right? I mean, the virus.
Yes.
So that's why you never have like full immunity against it because you get like somebody will get it, the CDC will run, get the virus and then make an antiviral.
Right, and it's a constant production, and that's why every year. They talk about getting the flu shot, and you're thinking, well, wait a minute, I just got it last year. Why do I have to get it again? And it's because of those mutations, that can occur. In some cases, you're going to be made to get the flu shot if you're in healthcare.
Yeah.
Okay. I don't ask me my opinion on it. But you know, the goal is, of course,
I was the same boat as you. I never liked them being forced to get the flu shot, but
I don't like anybody forcing me to do anything that I feel is against my rights as an individual. Anyway, so, however, there are going to be situations where you're going to have to. Me personally, my doctor always makes me sign a release form every year because she's like, "Are you going to get the flu shot?" And I look at her and go, "What do you think my answer is?" "Okay, sign this form." I have to sign a form saying that if I get sick, I'm going to sue her because I refuse to get the flu shot. So it's kind of, it's really weird. So you can get sick even though you might think you've got an immunity to something. It just means it's a different strain of it, especially for these viruses. So once the body has taken care of it, we will not restart right now. Once the body has taken care of it, though, but you've had to go through the getting sick and the fever and all that sort of stuff, hopefully it does create the T cells, the memory cells, and you're going to have immunity the next time you come across that same strain. When we talk about immunity, we can either have cellular or humoral, and not like ha-ha funny, okay? Humor meaning the fluids of the body, the humors. That's what they used to call blood back many, many centuries ago. So, cellular. This means cells are involved. For example, a lymphocyte that directly attacks and destroys the foreign cell or the diseased host cell. Like, for example, the natural killer cell that releases the perforins. Okay? Basically, that worked inside the cell. Humoral. I needed something to make an antibody. That means that when the T cell got activated, B cells came into play. B cells can make an antibody, something that has a specific shape that can move around in the blood. Okay, that would be humoral. In the case of an antibody, let's say T cell got activated, which called up the help of the B cell that can produce an antibody, in that B cell that could produce antibodies, bunches of them, okay, that cell burst. And when it burst, those antibodies are now in the blood. Does that make sense? If the pathogen that's flying around can fit into the antibody, that antibody has now tagged that cell. And it's basically like, okay, I got it, come here, kill it. And that's what's going to happen. So the antibodies tag the pathogen, and the body has mechanisms to come over and say, okay, got it, good deal, go get the next one. I'm right behind you. That is pretty much how the antibodies are going to work. So this is working outside of a cell, meaning extra outside cellular.